we out of storage. Oh, so Dev Shumer was saying that we are out of storage, but that's not important. Welcome to DevKami, number 215. Chi Liang is busy today. I'm swimming.
I am Tristan.
Cool. So just now we're actually talking about this thing. Let's start with concept a bit before we go on. That won't be a main
Mm.
project, but it's an interesting one. It's called the RPi Pico Maker Party by Citron, by our friend Citron. Uh, well, more like you get the idea. So it's
I actually have one
the
of
thing
those
is
already. So that's
correct.
this one.
So
Well,
you
I'll
you
have to disconnect it. Like the
oh you want to display it?
pie. Oh, yeah,
Correct.
that's okay. It's one of these. It's quite nice.
Yep. So yeah, actually a lot of people like this. Some of the OC makers online realize that they actually like some of these Citron devices. The reason is they're made in Malaysia, so they're cheaper compared to US, and it's really good price and very good I/O. So a lot of people like it. Will look at
Yeah,
their
the I think
pictures.
the the key here is the extensions, right? So for example, this
Correct.
is the Pi Pico Maker, I think, right? So you have
Yep.
the normal, like this one is the Pi Pico.
Yep.
So, but you have all of these like GST, whatever, I forgot what they
Correct.
call it. You have a SD card reader, you
Co-
have a
correct.
buzzer, like whatever standard
Correct.
this is, the 4-pin thing that they use for
Oh
Groove or
yeah.
whatever. Like the brand is Groove, but
We
there's a
Groove
standard.
connector.
Then
Yep.
you have LEDs here. You have like the
Correct.
switches and all of these things. So it's useful if you don't you have a ESP01 header. So it's useful
Yep.
if you don't want to breadboard yourself. It's just there. You plug things in and you can prototype a lot of
Correct.
things. And this one has like the pin male header pins so that you can put
Oh,
like let's say um,
I showed the wrong one.
wires as
It's this
well.
one.
Yeah,
Correct.
it's this one. So
So
the
this
other one has this one has the soldered in Pi Pico. The other one,
correct.
that this one is Pi Pico sold separately, so you can replace
Yep.
your Pi Pico. But this is great if you just want to
Correct.
prototype something with your Pi
Correct.
Pico, and then
Correct.
uh,
So this
yeah.
one is a
So you're
prototype, but
saying
the other one is also very cool because uh, this one actually have the whole thing, including motor controllers. So you can
mhm,
just build a whole robot just out of this actually, if you want
yeah.
to,
So this is
right?
not using a Pi Pico. This is the RP2040 chip itself. So it's
Correct.
the small thing there just below
The
the
microcontroller
LEDs.
itself. Correct.
Yeah. But because it's not, you don't need the rest of the GPIOs. The rest of the GPIOs are already taken up by the buttons, the IO, the motor controller, etc. So you don't really need
Correct.
those anymore. Hmm.
Correct. Then they also have these guys. By the way, we are not sponsored by them.
Yeah.
We just love them so much. And
Hmm.
apparently the stock is better now, so it's possible for you to
Yeah.
get this.
Yeah. So
So
this Pi
again,
Pico
yep,
is actually the same as this, except that it's smaller and it's like the reverse side, right? So
correct.
they're using it's almost the same IO, but of
Yes,
course it's just mini.
correct. So either way, the reason I talk about that is because of there's a competition. Uh, Not a lot of money, but it's fun. So Tristan have an idea to build a PID system, right? So a
Yeah,
PID system
so
is actually
PID is
uh,
if you know about the two-wheel balancing robot, so that is using a PID control.
wrong PID
Yes.
microcontroller,
No, PID control
microcontroller,
system.
a controller, right? Yeah, this is one
Yeah, it's a
PID
PID
controller.
controller system.
Yep.
Yeah, it's a proportional integral derivative. So
Yep.
the naive way that you're going to do about it, let's say you want to target a particular temperature. The naive way of you're doing about it is if the temperature is above this, you turn off the power supply and the whatever heater that you're doing. And if the temperature goes below, then you turn on the
Hmm.
power supply or the heater or
Correct.
whatever. But the problem there is that you're always going to swing very, very widely. So
Correct.
that's the proportional part, right? then you'll have like your integrative part. Then when you start like inching in closer and closer, and then you have your derivative
Mm-hmm.
part, which like makes it even more precise to target it. So if you're doing something like a two-wheel balancing robot, initially it will like move very far until it
Mm-hmm.
feedbacks itself, like how what's the angle of all of these things, until it becomes smaller, and then
Yeah.
it's like just vibrating here. So it's the
Correct.
feedback control is very important there, so that you don't swing too much on either side of
Mm-hmm.
the target. And the
Correct.
PID controller is, I mean, it's overkill because you're dealing with temperature of water, which
Mm-hmm.
water has a very high um, heat capacity. So
Correct.
you don't really need to be very accurate there. It's just like one way of doing it. I mean, might as well go bonkers with the algorithm, right? Uh, but
Correct.
the idea is to use something like that to target a specific temperature that's good for doing sous vide. Sous vide is a way
Mm-hmm.
of cooking where you, what is this? Oh,
Okay, I'm doing
you're
my
I think
stuff.
it's
Sorry.
yeah, it's a bit noisy. You probably
Oops.
want to
I
move
didn't
it away
realize it's
from
big.
your microphone. Yeah.
Yeah.
So it's good for cooking. It's an alternative way of cooking, let's say steaks, for example, or eggs or whatever,
Mm-hmm.
without frying it, without subjecting the food to very high temperatures. Uh,
Correct.
the reason why you cook food is mostly to kill bacteria, for example, right?
Correct.
And at a
Correct.
certain temperature, around like 50, 60 degrees Celsius,
Mm-hmm.
for a long and you maintain that temperature, bacteria cannot survive, and so it will be killed.
Mm-hmm.
But the reason why we cook it at a high temperature is because you want to. It also changes the chemistry. So fats will melt, and then the protein will like
Yep.
coagulate, and all of these things. Uh, it changes the food. So sous vide kills
Yes.
bacteria without immediately changing the food. So there's a different way of, it's a different technique of cooking. And steaks, for
Correct.
example, are a great example of cooking by sous vide. If you've
Mm-hmm.
eaten steaks in a hotel, or like in a restaurant, most likely it was cooked sous vide and then
Mm-hmm.
taken out of sous vide and then fried, so seared,
Mm-hmm.
so that to seal in the flavor. Because you can sous vide it, so you can take it away from the fridge, sous vide it, maintain it for like 3 hours, just keep it at that temperature at 60 degrees, and then
Mm-hmm.
when the customer orders it, just take it away from there, and you sear it, and the food is not going to spoil. So that's an there are professional sous vide machines. There are DIY sous vide machines, like
Yep.
I think the most popular one is Anovo or something. I forgot. It has like
Mm-hmm.
a spinning fan that circulates the water, etc. So I'm doing it the hobo way. So I have a hot pot. I'm going to
Okay.
put a Sonoff, so it's a
Uh-huh.
Wi-Fi with a relay,
Yep.
and then you have
Yep.
your Pipico W that has a
Mm-hmm.
temperature sensor, so it senses the
Yep.
temperature, targets 60 degrees, let's say, and then
Mm-hmm.
turns on or off the relay through Wi-Fi. And then, of course,
Right.
the feedback there is the temperature, the temperature probe. I think a
Right.
DS180 single wire.
Correct.
I might be using Circuit Python because the Pi Pico has Circuit Python by default, so that's
Correct.
just
It's a very
convenient.
capable board. It's
Hmm.
a very capable board with dual core and all the shebang. Seriously.
Yeah,
So either way, the competition registration should end. When should they end again? You need to give
26,
it by
21, yeah, 21,
twenty
and
first.
then 27 is
Yeah. So you get all
so
that,
I
and
already
then you
registered. They already gave me the 50% discount coupon, so it's actually quite
right.
nice. So you know that those prices, I
Yeah.
slash them by half. That's how much
Right.
they sell the thing.
And
So
it's
you
actually a
can
very
buy
cheap
like
board.
5 of them, and then you get that discount 50%. It's good.
Correct. So my thing now is that I want my focus now is on deep learning stuff. So not really deep learning, so more like chat GPT, large language model stuff. So I'm trying to do that. So if I can have some idea how to integrate that to here, maybe. I highly doubt it because the W is a bit hard, and also we need the API is a bit fat. Okay, put it this way. So
Well, the thing is, you don't need to run the code on the Pico W. It can be the
Correct, correct,
interface, right? It can be the edge
correct,
device.
correct.
And because the W has Wi-Fi, then you can always
Yeah,
send data back to your main computing device and then send the results
correct.
back to the Pico if you need more feedback.
Precisely, that's an option. So yeah, maybe
Mhm.
I don't have a strong idea yet. But let's go back to DevKami. So if you have one event, this is one event you should care about. The second event is we don't have other event. In fact, just now what happened? We have a AWS meetup. So I'm
Yeah, it
fairly
was
sure
yesterday,
people
right?
might.
How was it? Did they record it?
No,
What?
they
How
record
come?
they record the yesterday was a DevOps meetup. Today is
Ah,
a
DevOps.
AWS
Okay.
meetup by the
Ah,
AWS user group. The DevOps meetup was good. Yesterday is about sponsored by Confluent. Of course, they will talk about Confluent. Confluent have very interesting technology. They do beyond just streaming, or I would say data. They do beyond a bit beyond just broker in a way.
mm-hmm.
So yes, if you want to look at high level, yes, they're yet another broker, but they do quite a few interesting stuff like you can you can have a filter on the broker itself, so they only get certain data while other people get the same data. You have the ability to store the message indefinitely, very useful for audit or recovery, disaster
Mm-hmm.
recovery. So let's say you want to resend and all that. Then they have of course they have message validation on the broker itself, so you can have safety checking and all that validation, all that. So Kafka is very interesting, right?
Mm-hmm.
But then the second one is actually by the Mind Valley team. Okay, I'm going to say something very bad. I do not know what they do, but apparently they have a very interesting deployment system, internal deployment system, Wukong, which actually do things like interface with Jenkins, Spinnaker, then copy message to Slack, etc. They got very interesting capability. A bit overkill for me, but yeah, if it's helpful, it's helpful.
Well,
Uh,
it's probably again. So you mentioned about like your previous colleague
yeah,
coming in and then going out. That's those are usually what happens when you have someone who um, who comes in strong, but then wants to change things a lot, and then
yeah,
like leaves something. So it sounds different from what I remember, but
yeah,
that's probably what happened.
correct.
Yeah,
So
so
I
the rest of
okay,
the team is
but
probably just like left with maintaining the thing because it works, but it is a bit complicated.
correct. So it's either okay. So I have a very biased thinking. So it's either the reason why you have a dedicated deployment dev tools and all that is because either the product is complicated or you have the time. Sometimes, so I do not know how that is that, right? It's a cost thing because I'm currently in a startup-ish environment. Startup-ish in a way because we pivoted and we are very lean now. So we kind of push a lot of feature which bite us in a few time, but we know that we remember the consequences. So for example, this morning, our Rails is so outdated. The Docker image doesn't work anymore because the that one is built when Docker is still using Debian Stretch and Stretch is not supported anymore. So it's very bad. It's horrible. So we begin to put stuff in the roadmap. I mean, we have to patch the thing by using Alpine. Then we start the roadmap to upgrade our Rails system.
Mm-hmm.
So I'm currently in an environment where uh, we have lots of work to do, right? Well, try to balance things out, but so yeah, we have complicated situation as well. So, but we don't have time to build a dedicated build system, right? Even on I don't have this kind of time anyway. Until we have, yeah, you get the idea. So either way, that's yesterday. They actually made a recording. It's cool,
Nice.
and also,
Did they
yeah,
on Engineers My or somewhere else they on their own?
I do not need to ask Tavern, because
Mm-hmm.
I do not know how they pass it to Tavern.
Mm-hmm.
So that happened. So yeah, that's the only thing that happened for the past week, and for the next weeks is essentially tech up, and that's about it, really. So
Next,
until
so this weekend is the Imagine Hack at Taylor's. So my company is
oh,
sponsoring it, and I'm doing a workshop on the Sunday at
imagine,
Imagine Hack.
oh,
It's
was
a
it like a
hackathon
Microsoft thing?
since starting. I don't know. It's a Taylor's college thing, Taylor's University.
Okay,
Sorry. So and I'm
okay.
doing a
So,
workshop. I'm just answering
mhm.
questions. So it's like DevKami by myself on
Okay,
Sunday.
okay. If you need
If you
help, you
want to
can go
go, you
because
can
there's
go
a lot.
on Sunday at 1 p.m. Yeah, my slot is at 1
Okay,
p.m.
let's see because I might have things to do. Let's see, maybe there's something.
Yeah.
So
The
okay, so the
topic
reason
is
why,
sorry,
uh-huh.
yeah, the topic is just like your a daily life of a software developer, and then I'm just going to answer
Cool.
questions like, should I quit school? And
Okay.
then it's always going to be it depends. Like if
Yeah.
so I'll talk about like information asymmetry. Like if you
Hmm.
there's less risk in staying at school because uh it's a good proxy for work environment, and so
Correct.
your ability to learn is not actually what your employer is buying, but rather that
Yep.
they're making a gamble on your potential,
Yep.
and the less risk they have, the more likely they're going to hire you, and the better grades you have is perceived to be like better risk, like yeah, less
Correct.
risk. Whereas you can start your own business and you can start your own, or you can start coding by yourself, but that's very risky because
Hmm.
there's not a lot of people who know what you're capable of, something like that. So
Yep.
lots of interesting questions.
Correct. Cool. So that happened this weekend,
Mm.
and that's about it really. Uh, I still do the CFP, papercore.io, and last one, papercore.io/PyCon my 2023. Yeah, let me find it. Papercore. Okay, here you are. Uh, so PyCon Malaysia is still happening. I do not know how many people already submitted, but please submit paper if you're interested. Apparently, they got 12 people, but they don't show it here lah. So this is happening. So do your paper if you want to share something interesting on Python, and that's it. So let's quickly go through the news because I want to do a book review. So the first one is uh, why fsync is important. So you know what is fsync,
Yeah, it purges your file buffers.
correct?
Well, it
So
writes everything in the buffers to the actual disk
mhm,
or drive.
correct. So you need this for your application for safety and all that. So the problem is you need you so no question main vulnerability is without fsync. Uh it cannot can withstand without computer data consistency. So uh you need this even though on the replicated system because some of these systems are on buffer, it's on buffer, and if anything fails, you just lost it, right? So you need fsync for this reason. Uh, so this is a very good example. You know, this is about books. This is about why fsync is important, and even though you have a multi-core system that is supposed to be reliable. So
Hmm.
yeah, it's actually very cool, very deep. You should read it. I'm going to move on. Anything to add before move on?
No, no.
No, then okay. So this one, I don't think most of us have this kind of problem other than them. So you know it's rough.
No, what is rough?
Uh,
Your life is rough.
it's rough
Life
is
is rough.
actually
I'm
it's
just kidding.
algorithm to synchronize. It's actually a way to create a quorum. Rough algorithm. So it's a consistent algorithm which is alternative to Paxos. So you
Hmm.
use this for a multi-location system to get consistency, right? And it's actually proven to be safe, formally proven. So the idea is, it's actually, the thing about Byzantine general problem. In this kind of thing, how do you synchronize information across multiple machines, where things cannot be 100% reliably synchronized, right? You
Mm-hmm.
need this. You need this to ensure that your database are consistent, your time system are consistent, etc. And they do that with a leader election and all that. It's very cool algorithm. You don't have to deal with it all the time, but multi replicated database use this kind of algorithm for you to make sure the data is consistent across the replicas. So they also use this to maintain state of machines, FIFO queues and all that. So uh, up to a scale is actually very useful, but we can avoid it way before that. You know what I mean?
Mm-hmm.
If you use some database, they do it for you already. But this is very cool because they actually tell you why that you need to care about why Meta, aka Facebook, use this, and how they do this, and why it was necessary. The short answer is because they have a lot of database around the world that need to be consistent. So rough listener and all that. So yeah, this is MySQL had a rough plugin that you can use, and up to a certain scale you can use this to make sure that your replica is consistent. Facebook is a bit more crazy in a way that because they have multiple multi-region databases, they can do that and they need to do that because this for data safety lah. So yep. Anything to add? If not, I'm gonna move on.
No.
Okay. This is one hot topic. I did not test this. The author claimed to test this. I did not. So consider this as your catalog of prompt in ChatGPT. I do not know whether this is useful for Copilot. Oh, which Copilot actually X is out released for some people today. Uh, so yeah, have you used Copilot already?
No, I don't think I have.
Right. I find it very interesting because apparently I use it wrongly. So okay, so
Mm.
the context is this. Okay,
Yeah.
one of the things that I have to do for this week. Okay, well last week, let's say last week, I have to simplify. So our annotation tools can only accept certain number of points, right? So to do that, I
Mm-hmm.
actually need to implement an algorithm to simplify the polygons. So what we use is we use a reverse shingle algorithm. So so what they do is essentially calculate triangle. If anything that's too small, we just don't care and just remove the point, then we calculate. So the problem is, so here's the interest where things interesting. I would expect, because this algorithm exists since the 1990s, and
Yep.
it's a well-known algorithm in GIS system. So when I use Copilot, I ask, please implement reversing the algorithm. They do not get it. They do not understand this. But when I actually implement uh, this step by step, I get it. But my friend would think that it does not. I use it wrongly because
Mm-hmm.
let me get this algorithm. What algorithm? Give me one algorithm. It's wired algorithms. Wired algorithm. Yep. Viva Lingam. Sorry. So when I ask the algorithm to implement this algorithm that do not get it, I need to tell them the step of it before you do it. So yeah, I find it interesting that yeah, they will get it, but sometimes it just ends up like a human version of the code really. So that would work, but
Yeah,
sometimes
but does
it
it
does work, but
does it
not
speed
necessarily.
up your work, or I mean that's the
Yeah, in a
biggest
way,
thing, right?
yes. In a way, yes, because I'm writing a command anyway, right? So previously the code don't have command. Now there is command, and the command describe how the code works. in a good way. In a good way. So
Mm,
it's a high level enough thing that to describe to people use. But what it doesn't do is it doesn't work for advanced algorithm. I would call it that. So yeah lah. But it works. It works. Not as good as all the time because one of the job I like to say is that I want to make Copilot to make a idiot sandwich because sometimes the style is wrong. Sometimes
mm-hmm.
they pick up the wrong code and all that with the wrong assumption, so it's not great. It's good sometimes, but not all the time. It's a mixed bag. So yeah. So yeah, this you can try it, see whether it works and tell us. So next one is new TLD. Bad idea. I have some bad idea
Mm.
here. .zip is a bad idea. Yes, they meant to use trackable links, but .zip is also a way for you to create, potentially create a phishing link. The only catch is I do not know how uh, how they can try to escape the slashes and all that. But yeah, .zip is a horrible idea. .move is also a horrible idea, to be honest. But yeah, they already created it, so that happens, lah. So what do you think?
I don't
Before
know
I
if
move,
it's a bad idea, but it's just
yeah,
complicated. Like a lot of these TLDs are now complicated. But maybe it's
correct,
just removing the the special status of .com because
correct,
it's already like what they call this uh,
correct.
saturated. There's a lot of
Yep,
replacements like .io seems to be the next thing, next best
yep,
thing, and then there's I don't know, I think that's the next the most popular after .com.
yep. But AI
I
is
don't know
hot
the
because
others.
of AI, so it's this. So yeah, lah.
Uh, I
So
think
this
is
one
.js a big thing? I don't know about .js.
I don't know about that as
Is
well.
there .js? Yeah.
There's .dev, which you is meant for you to do that, do this or .code and all that. So I'm going to move on quickly. So core utilities to be written in Rust again. Yeah, they have some good idea. Overdue, but it's a good idea. So if they can make it work and make it compatible, I have no problem with it. So because sudo and su is damn old. Okay, it's damn old. So it's written in unsafe language. Occasionally people do find vulnerability. So Rust can help law. So anything to add?
No.
I'm going to add that. Windows hardening, it exists, and that's about it. I'm going to quickly go through the last few one, last two. Vimeo is actually a tool. If you do not do EDA, you kind of don't need this because this is very workflow specific actually. So this is actually a way for you to build blocks and build use script to build UI, and people use that to build flows to do stuff. Most of the time you do not need it, but it's useful for people to analyze the data, sharing stuff. Because put it this way, I don't think it's a good idea. Okay, I believe in empowering people to build their own tools when necessary, right? If you have tools that make it easy for you to do your work without turning it into a sprint, I'm all for it. Okay, even though for you it may
Mm-hmm.
be a sprint type spirit, but I don't think all tasks need to turn into a sprint size for a sprint size. I mean 2 weeks lah, right? One sprint, 2 week sprint for a software engineering team to do. So if you can write a code to make it easy for you to do stuff, I'm all for it. So in this case, what they do is they can use you just define the specification, call API, and do the work lah. Then you can from there you can build. Then from here you can build some API for you to do work, and you can use this to, for example, scrape website, handling your inventory based on database or spreadsheet or whatever.
Mm-hmm.
And yeah, so and I will not just the code you use. The point is deliver, make something useful, and that's about it.
Yeah.
And yeah, that's about it. I'm going to move. And finally, the last one, we go, which will be segue to the next one. Maurice Tenenbaum. He actually worked in Bell Labs. Then he go to He actually do the first transistor and all that. Yeah, first silicon transistor, all that. So rest in peace, but it's very cool because I'm going to segue to the next thing. Okay, I want you to ask a few questions. Uh,
Hmm.
I want you to talk about, tell me what information technology tools in general that happened starting from just before World War One, just before the 1900s until
Before the
until now.
1900s,
Just slightly
technology,
before
you
the
mean?
1900s. Yeah, information
Technology,
technology. Yeah,
information
back,
technology.
yeah. So what can you think of?
I don't know. I don't think we had information technology
Yes, they do.
before
You
the
got Morse
1900s.
code. You got Morse. You have
That's
Morse code.
sorry, 1890 something, right?
Uh, Actually, Morse code is created in 18. Morse code is created by Samuel Morse in.
Because that's like
Uh,
you need to have
oh shit!
electricity working at
Correct.
the something, right? So I don't know if they actually have a working theory of electricity by that
Electricity
time.
exists. Electricity
I mean,
exists.
yeah, it's a theory of electricity, like actual like
No, no, no.
voltaic cells, for
Electric
example.
generator exists.
Mm,
Exists in 1836. Okay, Morse code. So describe electromagnetism, then the circuitry, but it's implemented in 1841, right?
mm.
So
Oh,
then
this is a
what is
telegraph. Oh, yeah,
1844?
okay, yeah. Mm-hmm,
Okay, so this is one
mm-hmm,
information technology. Then you have electricity, but electricity generator exists way before that. Generators, generator exists in the early 1900s, but of course you talk about that, so that count, right? So it's actually invented 1831. But the large scale one are created in 1812. So you have big enough generator, 7 volt and all that. So it's enough for telegram machine. Okay, it's enough for telegram machine. 1900, you get a AC generator for large scale electricity.
mm-hmm.
So it exists. So what other technology? I want you to think about that. That's starting from early 1800s before first.
Yeah, I think that's what I can think of.
Well, you also have uh, you also have
Mm-hmm.
telephone. Okay, telephone. Telephone is created in the okay. So 1816 have one, right? 1876 have one.
Mm-hmm.
This is very important. Remember this. Then of course you finally have vacuum tube, right?
Oh, vacuum
Vacuum
tube
tube.
is your transistor type thing.
Correct. 1904. So very early on.
Yeah.
This is very important because now when Bell Labs when they first created, they are they are founded by Bell, as in the creator of telephone. It's not creator telephone, but it's one of the creator of telephone. Okay, Alexander Graham Bell. So what he do is he built this technology so that this lab so they can dominate the market, right? And the goal here
Mm-hmm.
is to improve telephone. Because in the early days, telephone is not reliable. It can't go long distance and all that. So during World One, they do things like improving the basic technology, even though technology that is not very clear. Uh, One thing that do focus a lot is they focus on material science, how to improve the wire, what medium is useful for telephone use. They do a lot of uh, vacuum tube technology because vacuum tube technology is very useful to build transistor capability, so it can build amplifier and all that, right? So that's one.
Mm-hmm.
So now I want you to go toward after World War II. What information technology is being is can be is created just after, starting from World War II to until
Oh
after
yeah,
World War
so it's
II.
the war stuff, right? You have radar, you
Yeah,
have like
correct.
those communication things,
So
laser stuff.
ah, laser is created way back. So I'm going to give you a list. of this cool thing, then I'm going to give you the inventor. Actually, I already know the invention. So just before World War II, because they focused on vacuum tube because solid state technology didn't really work yet, they used radio exists way before that. Radio exists in the early 1900s. Marconi, right? The Titanic actually
Mm-hmm.
had a radio called the Marconi, and it's actually still on the Titanic, but not related to this. Then after that, they have uh, after that they improve radio technology because what Bell Labs are good at is actually doing math and signal processing and all that for telephone, right? So
Mm-hmm.
after that, after World War II, they're actually very good at material science, and from there they create transistors, solid state physics. So for some reason, solid state physics is weird. They decide to invest in solid state physics. Then from there, they created the transistor. From transistor, they got from there they built all the technology, but they did not create the microchip. A microchip, the chip is created outside, but all the technology is built by Bell Lab. Then they built the laser. They built the maser. Then they built the laser for radio. They improve the transatlantic cable. They built the satellite. I'm going to give a list. Okay, so there's a reason for that. I'm going to show you a book. I hope I can show you guys. Let me remove one. So can you see, or is it too bright? It's too bright. Forget it. Add to stream. So there's this book called sorry, I pressed the wrong thing. The Idea Factory. Idea Factory. So the Idea Factory is a book about Bell Lab. Okay, John Gurner. Highly recommend you guys to read it because it's also very cheap. So it's about Bell Labs, and it describes essentially. Okay, so let's talk about high level of this book, right? This book is really about innovation in a very high level. It's a history book about Bell Lab, of course. Did I turn off? No, okay. Oh, wrong tab. I'm so sorry. Let's close it off. So, high level, this book is about history of innovation. So it's about why people innovate, why company A invest in time in this, and why despite that company can still lose out. So on a high level, it's a story about that. So in between, they also tell you about the history of Bell Labs and what they have created. They, this is not a comprehensive list. So one thing they do not talk about is Unix. They barely scratch like they created Unix and that's it, right? That's it.
Mm-hmm.
So because that's not the big thing, they focus a lot on telecommunication technology. So, but they do a lot of important stuff. So I want you to think like they created the transistor. I will tell you that amplifier. They do the transatlantic cable, so that they can have a telephone services across the ocean. Then they created the fiber optic cable. They do the communication satellite, but the American government do not allow them to go into the satellite business.
Mm-hmm.
So monopoly for a reason. There'll be a lot of story about that. Then they created they have a scientist called shit. So the lab is the origin of information theory, which in turn is a basis of a lot of stuff like computer science and all that. Then I have lasers and all sort of stuff, right? So let's go through Bell Lab again. Bell Labs. Close tab. What the hell? We open close tab. Nope. Give me a while. So because we are nerds, we talk about technology as much. So Bell Labs, we software people have tendency to talk about software side of stuff. No, the most important thing about Bell Labs is really about the hard thing, the solid state physics stuff. And the reason is this: Bell Labs are created so that they can improve the telephone business. And at that
Mm-hmm.
time, Bell Telecom is a monopoly. So And the whole point of this lab is to build tools to enforce this monopoly with better technology.
Mm.
So, but to do that, they cannot be too much. They have to split it up so there is their own company. So that it's not seen as a tool for Bell communication lah. So that's one thing that happened, right? Still, that's the point of Bell Labs, right? And what they do is they have scientists that insider to recruit insider, then all that. So it's about early days about networking of the best people. So even though they are industry research lab, they do stuff that at that time not relevant, right? That's one thing they do.
What do you mean by not
Uh,
relevant?
so the idea of
Not
solid
relevant
state
to whom?
technology to building telephones, okay?
Mm,
At that
okay,
time, it's
yeah.
not really useful for making telephones, uh, telecommunication technology, right? And that's
Mm-hmm.
fine. It's very revolutionary at our time. Nowadays, it's thing like 20% project, big deal. At that time, uh, it's really unthinkable. In fact, currently in a Malaysian company, you try to do something that is outside of company stuff, you get
Mm-hmm.
fired, right? So you just don't get a lot
Well,
of this culture. We still don't get that
only
kind
if
of
they
culture
catch
here.
you. Only if they
Correct.
catch you.
So indeed, in Bell Labs, that actually enforces that, right? So
But isn't
because
that
of
like
the today's rule,
the the source of like 20% time or whatever, like just doing
correct,
something
correct,
that mhm.
correct. So so allow me to talk about location. And then let's go to that. It's a very cool story, but not the most interesting stuff and not their focus. What some of the focus is that, for example, they invented statistical process control, so they can manage large scale process. They do motion picture. They're not that important, but it's there. Then this thermal noise. This is more important. Thermal
Mm-hmm.
noise is very important because you're building long-term electronics, phone and all that. You really need to measure this. So you need to analyze the capability of this system. Then 1928, they built amplifiers. This is very useful because telephone, at that time, in the 20s, they really focused on telephone technology. Even though the
Mm-hmm.
maths is weird, but they decided to invest on this. And one of the things is they do get stuff out. So in this case, they have the amplifiers. Amplifier is very useful so that you can have phone go on a longer distance, right?
Yeah.
So because it's a feedback system, and all this is because the thing that invest in things that is not directly relevant to phone. It's signal processing actually. So at that time, people think
Mm-hmm.
like, okay, signal processing may be useful, but how useful it is, nobody really knows yet. So 1920s, 1930s, they built a radio lab. The radio technology is more useful further in the future, but it's that they actually invested in it because it's the same lab that actually do the cell phone. Because you need theoretical
Mm-hmm.
basis of radio to build the cell phone. But that's toward the 1970s. 1940s, they created the photovoltaic cell. Not really relevant, but it is there. Then they made Claude Shannon. Who is Claude Shannon? Guess.
No, I have no idea.
He's the creator of information theory. So, and
Mm.
information theory that
What is information
talking about,
theory?
I'm going to open up. It's a way to describe information actually in as a maths. So one of the things is that key measure of information is entropy, meaning so one idea is I want you to imagine traditional telephone. Nowadays phone is digital, it's hard to imagine. I want you to think about a noisy telephone, right?
Mm-hmm.
Interference and all that. So what you can do is you can send one message to another, but you have noise because background have noise. But this noise can be measured. As a result, you can use maths and formulas to improve the noise by looking at this probabilistically make manipulate and make improve your communication, for example. So there
Yeah.
also information theory is the basis of error correction, uh, uh, compression, all that. So uh, so information theory is the basis of computer science, telecommunication, modern telecommunication technology, etc. Right? So uh, yeah. this is actually this is actually the computer science equivalent of the general theory of relativity. All right. So
Mm.
this is the basis of when we do about information, statistical information, we talk about information theory, and it's by Claude Shannon. Claude Shannon at that time worked in Bell Labs. Okay, worked in Bell Labs. Uh, so 1940 is wrong because there's a war, but they do they build computers. But the more interesting thing is information theory, uh, zone melting, which enable purification. Now, this is very important because to build transistor, you need certain certain purity of a certain purity of your material. Okay, so once you have this and level doping, you can build your transistor. So it used to be transistor
Mm-hmm.
is something you assemble, but with doping and all that, it means that you can grow it as a crystal and you can get a one-piece transistor which is more reliable. Okay,
Mm.
more reliable. Then you build the transatlantic telephone. Again, only much later that they built this to improve their business, right? So they do material
So this
science,
is going to Europe then, because it's
correct,
transatlantic.
correct. So at that time, that they do not use transistor, but they use vacuum tube. So they actually use the thing that they know about and design transatlantic telecommunication, which is actually very cool. It's a whole technology itself, and you need active component, which is so obvious, right? You need active component to actually push the signal further, so they have a relay system. So they do that. Bell Labs are the one that first created that. Music not that important. Here's one MOSFET. So this one is how you build one single component semiconductor so they can build all sorts of stuff, right? So 1950s, 1960s, Bell Lab is about transistors, solid state technology. Then
Mm-hmm.
1960s, they built communication satellite, Telstar. Telstar is created by Bell Labs and it's the only time Bell Communication, it's the only time Bell Communication are allowed to launch a communication satellite. The reason is monopoly.
Mm.
Oh yeah, so in between 50s 60s, when they created the transistor, uh, they had try guess how they actually bypass the whole monopoly thing uh, to to make the government happy, U.S. government happy.
Yeah, they create shell companies.
No, so what they do is they create license. So they essentially
Mm.
give transistor and give it to all the companies samples and see what they can do with it, right?
Mm.
So at that time, the reason why transistor is useful in theory is because vacuum tube is brittle, it's a glass tube, and it's hot. It takes more energy to run, right? So
Yeah.
semiconductor can be more reliable in theory. Only much further than make it up to a level toward the 60s or
Mm-hmm.
so. Only they have that, but you have the in theory you have something smaller and all that, right? So what they do is they make
Mm-hmm.
it licensed and cheaply, so they make some money and everyone get access to technology. So this is how they appease the U.S. government at that time. So 1960s, here 1969 they create Unix and that's it. Then charge coupled device again, uh, again in Bell Lab. Okay, charge coupled device. You don't just use in camera. You use in your it used in fiber optic communication system or anything that requires light stuff. You will need this again,
Mm-hmm.
and they got the Nobel Prize, right? Nobel Prize. So I'm going to count already. Modern day semi wait. Let's start from the bottom. Amplifier, semiconductors, which lead to transistors and MOSFET. Then now we have charge coupled device, telecommunication satellite. Seven of the stuff, and almost all of those are core. Those are the core of uh, the modern day information technology, right?
Mm-hmm.
Then they have picture phone. I want to give picture phone is very interesting. I'm going to stop with that later. Then they create electronics technology, force feedback, C and all that lah. They also have their own microprocessor. Then that's about it really. Uh, then there is the whole cell. Okay, TDMA. 1980s, they pushed cell telephone technology, right? So now these were things. So they have done. They actually tried to push large scale cell phone technology, cell tower technology across the United States at that time. Now, picture phone. Now, picture phone is the first thing. Is is essentially a sci-fi version of your Zoom call in the early days.
Mm.
This is actually very cool because the marketing people actually thinks that this is the future. They want to sell it very heavily and all that. Everyone loves it, right? Everyone loves it.
Mm-hmm.
Uh, and at that time, they actually compete with cell tower technology, right? So, problem here's very interesting stuff. Uh, the marketing people do not think that cell phone technology is the killer app, right? They put their bets on picture phone.
Mm.
But as it turns out, once they put in the real world, nobody really want to pay more something more
Extra. Yeah.
expensive, extra
Mm-hmm.
for the picture phone, and you need to have extra setup and all that. It's just not that convenient. And they also discover something that is more obvious. That is very obvious. Uh, you can have the coolest technology, but if nobody are receiving, they don't have a point, right?
Yeah.
So they discovered that. Whereas cell phone technology got extremely popular because there's a strong business to use it. There's multiple people use it, and it's a surprise hit to them. So yeah, so at that time they actually bet between picture phone and cell technology. The cell phone people try very hard to get money, but the marketing people do not think it's be successful. Turns out that
Mm-hmm.
marketing people are wrong. Marketing people
Well,
are
yeah.
wrong, and they're right uh, for various reasons. So yeah. So in short, this is a very cool lab, and also I was hoping I can show some stuff. Okay, another thing that's to do it toward the 70s, uh, the person that create the microchip is Robert Noyce, right? Robert Noyce.
Mm-hmm.
Robert Noyce. He's the one that created the first microchip, right?
Yeah.
Question:
Mm-hmm.
where did he created it?
What do you mean where?
Uh, where is the first microchip being created?
I don't know about where though.
So it's actually created in uh, Jack. Oh, sorry, it's Jack Kilby. My bad. It's Jack Kilby. They do it around the same time.
That's
Jack
the Intel
Kilby
guy,
do it.
right?
He later go to Intel, but
Not.
he is
Yeah.
created in Texas Instrument. Texas Instrument,
Mm.
right? Fairchild, which is actually originally formed by a group of people from Bell Labs. He also has a similar technology. Now,
Mm.
here's the cool thing: all the technology that you need to create microchip is created in Bell Labs. They have the capability to create a microchip, the first microchip. Uh,
Mm-hmm.
why do you think Bell Lab did not create a microchip?
It's not related to telephone.
No. So the reason is uh, they do not believe that yes, you can create very small scale transistors and integrate together into one chip, so to say. Yeah, the technology do it, but the Bell Labs do not believe that they get the quality that they need. So the yield
Mm.
is lower and all that. But
So
Robert
it's more
Noyce
expensive. Yes, they're saying.
yeah, they say that it's just not scalable at their level. But whereas Fairchild and the guy that bet on it, and uh, the reason is yes, currently as of now, it's not as reliable as a yield to create, and there's a lot of noise. There's a lot of way it's not reliable, but technology can be improved. Manufacturing can be improved to have higher yield of chip. So they bet on that. Now, this is a very cool story because Bigger organization had a very different uh had different goal. Okay, have very different goal. Uh, Big organization need reliability because their name is on the line. So you can look at this in the modern day with Google versus OpenAI,
Mm-hmm.
right? Uh, Google created all the necessary technology nowadays for large language model based application. They have that. They can build. They have the insight, knowing that Google is a bit like Bell Labs. They can, somebody may have the application, but they do not release it, right? In the
Mm-hmm.
earlier days, it's very similar. I believe. I do not claim to know, but I believe that it's very similar at two levels. One, uh, at that time, the marketing people probably do not see the value of a
Wait,
chat-based
which
system like
one?
Bell Labs.
Google or Bell
Google,
Labs?
Google, Google,
Mm-hmm.
Google, right? They do not see the value of a chat-based system and want to focus on text-based search on the search engine. It's the same for Bell Labs marketing that do not see the value of cell phone system, and want to sell more of a something that is evolution of phone, the picture phone, right? Same thing. So this is
Mm-hmm.
one part. There's a second part. The second part is Google actually had internal thinking about the need of when you release a product, you need to reach a certain level before you are even allowed to survive that long.
Yeah.
So as a result, it's very possible that chat-based, large language model-based chat system got shut down early on because it just doesn't meet that level. It's the same for microchip storage in Bell Labs. Um, at that level, they need better reliability because they got their name in their line and cost and whatnot at their scale. Whereas OpenAI, they can take the check, they can take the risk now. So they only focus on one thing. Uh, the focus is only on AI system, not necessarily large language model. And they just release, then hopefully things improve the future because they can. So this is actually
Mm-hmm.
very similar. It's a whole circle again, but for different technology, for different reason. But it's the same scale of uh, same scale of business. Let's say that, right? Organization. So in a way, this, I can look at Bell Labs and think that this is like the big company, big tech of the 1950s to 1960s, and you see the
Mm-hmm.
circle all over again, right? So during 1980s, the U.S. government forced them to split up. 1990s, so the Bell Labs got split up, so it just doesn't go that far, lah. So yeah, uh, it just it just happens, right? Uh,
Mm-hmm.
so yeah, you should read this book. In short, you should really read this book. You should really read The Idea Factory. Highly recommended. I give this a 9 star out of 10. A bit long, but yeah, it's very good story, right? This is one. The next book I'm reading is actually called Dealers of Lightning. I did not start this book yet. So,
Mm-hmm.
what do you know about Xerox Park?
Uh, Mouse and all of these things. Steve Jobs stole
Correct,
a lot of technology from
correct.
them.
Okay, probably a bit more, and also I believe that even that Xerox actually do have idea to build a do want to take their technology to build a desktop technology around the same
Mm-hmm.
time. Probably just being the episode got mythologized a bit more. But I will read this book and give a comment. But it's a same type of book, and people do recommend it. But currently, I got distracted by a book about Bismarck, so probably I read this the next week or so. But so yeah, any question you want to know about this
No,
book? Okay.
no.
Yeah.
But how much is
So
it? Maybe.
it's 7.99 on Kindle.
Mm.
So it's not too bad on Kindle. If you go on Kobo, it's a bit more expensive. I bought a Kobo just because I want to this AW Kindle all the time. So it's called Idea Factory. 809, roughly that. So yeah, it's not cheap, but this is not a new book, but then it's still okay because the book Bell Labs actually the modern Bell Labs is doing very different stuff. Yeah, they have some innovation and all that, but that's about it. So you don't see the same thing, and I do not believe that Google is the one that will do that. But what do I know, right? So with
Hmm.
that said, you want to know? I will write a full review on DevKami and a few plays later. So let's see how it goes. So anything
Yeah.
else you want to talk about? If not, we're going to say goodbye now.
No, I think that's it. We'll
Yep,
see what we can do with the Pi Pico makers thingy.
correct. So maybe next week
Mm.
we can get your build report, right? You have something
I
ready?
don't know. I'm not starting because I have something up this weekend, so I'm not starting this weekend, and I'm busy
Yeah.
during
And,
the week, the weekday.
and this weekend I might have to I will attempt to fix my DS again. The screen is broken and all that lah. So it's
Mm.
broken either way. So there's nothing really. No, it's working, but the screen is yellow and leaking liquid and all that. So I need to fix it. I replaced the screen, but I need to solder stuff in, which I'm really bad with. Oh well, that's how it goes. All right, thanks for listening, and it's
Yep.
recorded on YouTube. So thanks. That's all. Goodbye, man.
Bye.
So
See
I'm going
you.
to start. See y'all, and I'm going to end
See you
podcast
next
now.
week.